Let's learn everything about right triangle trigonometry. We'll talk about what is a trig ratio, what are all 6 trig ratios. We'll discuss the trig abbreviations. We'll review with special right triangles. We'll find all 5 functions. We'll talk about angles of elevation and depression, and we'll look at a couple of trig applications. So with right triangle trigonometry, it's going to be important to remember you might have to do the Pythagorean theorem to find your missing side. We're going to keep everything with simplified square roots. So make sure you're simplifying your fractions, make sure you simplify your square roots, make sure you rationalize your denominator, and make sure your calculator is in degree mode for right now. So with right triangle trig, the trig ratios that we talk about, sine, cosine, and tangent, they are just that. They are ratios. They're a comparison of the two sides of a right triangle. Only works with a right triangle. You need to identify what angle you're at in order to figure out which trig function to use. So our trig functions, in a way that you can remember, is SOHCAHTOA, and that stands for sine, which is opposite over hypotenuse. So if I go to angle B and I go opposite, that's across from, and then hypotenuse, and I compare that ratio, that is called the sine ratio. With cosine, we have AH, which stands for, if I go back to angle B, adjacent means right next to, over the hypotenuse. So the cosine is the ratio of the adjacent side to the hypotenuse. And then tangent does not involve the hypotenuse. It compares the O and the A. So when you go to angle B and we go opposite to adjacent, that's going to be the tangent. So you can remember SOHCAHTOA to help you remember which way your ratios are arranged. We have 6 of them, so we abbreviate them: sine, cosine, tangent. We also have cosecant, which is CSC, secant, which is SEC, and cotangent, COT. So the last 3 were reciprocals of the first one. So when we have sine is opposite over hypotenuse, cosecant is going to be the reciprocal of sine, so it's hypotenuse over opposite. Secant is the reciprocal of cosine. Now, I see that sine starts with S and secant starts with S, and it would be really nice if they went together as inverses, but they're not. So cosine goes with secant. C with S, S with C. Don't mix those up. Secant is the hypotenuse over the adjacent. And then nicely, cotangent does go with tangent. It's the reciprocal, and it's A over O. Let's review our special right triangles. We have a 45, 45, 90 triangle. So again, we have a right angle, so we can use this. If I want to do the sine of 45, you can choose either angle. I'm going to go to, let's call this angle A. So I'm looking here at angle A. If I'm looking for sine, I'm going opposite over hypotenuse, which becomes 1 over the square root of 2. We need to rationalize that, and we'll be doing this a lot. So it becomes the square root of 2 over 2. For cosine, I'm going to do adjacent compared to the hypotenuse. So it's going to be the same thing, 1 over the square root of 2, which is going to rationalize to root 2 over 2. And then tangent is opposite over adjacent. So that's just 1. Let's look at our 30, 60, 90 triangle just to refresh your memory on them. The 30 degrees is always opposite the small side, which in this case is the ratio of 1. If that's 1, then the hypotenuse is double that, so it's 2. And then the side across from the 60 is always whatever the short side is, so we would have a 1 here, times the square root of 3. I'm going to erase all of that. So when I'm looking at sine of 13, I'm going to go to my angle, and I want to do opposite over hypotenuse, so it's going to be 1/2. Cosine is adjacent over hypotenuse, so square root of 3 over 2. And tangent is opposite over adjacent, which is 1 over the square root of 3, which needs to get rationalized and become the square root of 3 over 3. Now I'm going to erase all of that again, because now I want to turn my attention to the 60 degrees. And things are going to be different because now opposite is all the way over there. So for sine of 60, we're going to have root 3 over 2. For cosine of 60, we're going to have 1/2. And for tangent, we're going to have the square root of 3. Let's try to find the 6 trig functions of this triangle. So again, I'm going to go to my angle. I do see that I'm missing this piece here, so we have to do the Pythagorean theorem. So I'm going to call that b. So 3 squared plus b squared equals 6 squared. Make sure you're putting your 6 as your hypotenuse, as your c. So when we simplify that up, we're going to get b squared equaling the square root of 27. We want to take the square root and rationalize, so that other side is going to be 3 root 3. Now I have all of my sides. I can come up with my ratios. So the sine of x is going to be 3 over 6, which is 1/2. The cosine of x is going to be 3 root 3 over 6, which reduces to square root of 3 over 2. And the tan of x is going to be 3 over 3 root 3. My 3's can simplify to 1, and I rationalize, so that's going to be root 3 over 3. I like to line them up, so 3 and 3, and then I match them. So this is going to be cosecant of x is the reciprocal, so it's going to be 2. Secant of x is going to be 2 over root 3, which is going to rationalize to 2 root 3 over 3. And then the cotangent of x is going to be 3 root 3 over 3, which is root 3. Keep in mind, we're going to have some word problems. We're going to be doing the angle of elevation and the angle of depression. So if you're this person here and you're up at their eyeball and you are looking down at this ladybug, that means down in this direction, that's going to be the angle of depression right in there. If you are the ladybug and you are looking up at this person, that's the angle of elevation there. So our angles of depression is there, angle of elevation is there. Those are alternate interior angles in between parallel lines. So they are going to be congruent, but you need to make sure you draw them correctly into your picture. If I had a person standing here looking out and then looking down, this is not the angle of depression in there. This is the angle of depression that we're looking at. So let's try this. We have a builder building a wheelchair ramp from the ground to a deck with a height of 18 inches. The angle between the ground and the ramp must be 4.8 degrees to the nearest inch. What should the distance be between the end of the ramp and the deck? So the first part is drawing a labeled picture. So I have my deck is up there, and then this is my ramp. And this is my deck. And it's with a height of 18 inches. It is interesting, this problem is in inches, not feet, so pay attention to that. The ramp must be 4.8. So we're talking about this angle here, 4.8. And I want to know the distance between the end of the ramp and the deck. Distance between the end of the ramp, and the deck up to here. So I did not do that. I didn't bring my phone up. I'll take my jacket. Sine of 4.8. 18 over the ramp. 18 divided by sine of 4.8. 215. End of the ramp. Attack. What do I want to do? Shit. To end of the ramp. So, sorry for the confusion. We are looking for this piece here. We would already know how long our ramp is. So what should the distance be between the end of the ramp and the deck, we'll call that x. I go to my angle and I see that I have the opposite and the adjacent, which means I'm going to be using the tangent function. So I'm going to do the tan of 4.8 equals 18 over x. I would multiply both sides by x, so I get x tangent of 4.8 equals 18. Notice I put the x in front of tangent. I don't like to put it after because sometimes it gets stuck in the tangent. And now I'm going to divide by tangent, so x equals 18. Divide by tangent of 4.8. Make sure you're closing parentheses, make sure you're in degree mode, and you should get about 214 inches. Here we have a person on a boat, so our boat would be down here, and they see the airplane up there, and the angle is 34.6 degrees. They are 200 feet apart. And with this one, we are talking about the horizontal distance, not the diagonal. So this is 200, and we want to know how high the plane is. So we're looking at x. I go to my angle. I see I have opposite and adjacent again, which is tangent. So tangent of 34.6 equals x over 200. This time I can multiply both sides by the 200. And I am, again, going to put the 200 in front of the tangent word so it doesn't accidentally get the tangent. And you're just doing 200 times that on your calculator, and you get about 138 feet. Here we have a 12-foot ladder placed up against a wall. Here's my wall, my ground, my ladder. And we know that that's 12 feet. We know it reaches 10 feet. This time we want to know what is the angle at the bottom where it meets the ground. So again, I go to my angle, I see what I have, opposite and hypotenuse, so that's going to be sine. So I'm going to do the sine of x equals 10 over 12. This time I don't have my angle measure, so I need to undo the sine, which means inverse. So I'm going to do x equals the inverse sine of 10/12. And you would hit that blue button on your calculator and then sine, and that's going to give us about 56 degrees. So to recap our right triangle trig, it is only used for right triangles. Draw your label diagram, take your time, make sure all your numbers are on there and it's in the correct spot so you can get the problem correct. Determine which sides you have. Do you have the opposite, adjacent, or hypotenuse in order to figure out which trig ratio you need to use. If you're finding a side, you will use the trig ratio. If you're finding an angle, you're going to use inverse trig. Make sure you simplify your radicals and fractions along the way. Nice job.